Welcome to the Real Python Podcast. This is episode 26. Why is Python pulling in so many new programmers? Maybe some of that growth is from Python being a full spectrum language. This week on the show, we have Michael Kennedy, the host of the podcast Talk Python to Me. Michael reflects on 5 years of podcasting about Python and many of the changes that he's seen in the Python landscape. We discuss several stories about the different ways that Python is currently being used and how that is drawing in many new programmers. Michael covers some potential Python stumbling blocks of async, the Python Global Interpreter Lock or GIL, building desktop apps, and type checking. We also talk about how podcasts can act as a form of language immersion. So let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Well, welcome to the podcast, Michael. It's great to have you on.
It's fantastic to be here. Thank you. I'm excited.
So I partly wanted to have you come on to talk a little bit about kind of the landscape of Python. I'm newer in the world of Python programming specifically. I was programming in a lot of other languages and sort of landed in Python two and a half years ago and started to really dig in. And I wanted to have you on to talk a little bit about your history with Python over the last 5 years and being this, podcast host with your show and some of the changes that have happened over the last 5 years, and we can kind of dive into there.
Well, yeah, that seems like a good place to start, right? Go, where have we been and where are we going? I think when I got into Python, probably 6 or 7 years ago, I was, getting into the language, and then the podcast, I did that a little bit after, not much after, actually. I was pretty new to Python when I started podcasting and I started Talk Python to Me and whatnot. I did not start that podcast because I thought I'm this expert in Python. I wanted to hear stories like the one that we're going to share today. But there were no podcasts. I'm like, well, my first thing was I really want to get into this ecosystem. Let me find the podcast. And there's no podcast. So I'm going to have to do this. So my journey started pretty close to around then. And it's kind of amazing to see it. But that was the heated debate of whether Python 3 is just wrecking the community or is actually a great thing, right? Like it was still a debate of whether you should even bother about Python 3 and does it make sense to migrate your program over to Python 3? And, looking back from 2020, that's a ridiculous statement. And I was always on the side of, I don't understand why you wouldn't want the new library features. And all the core developers were working on CPython 3. They were not working on it. So like all the energy at the foundation was being put into Python 3. And so it was confusing to me.
Yeah.
But I think we've actually figured that out. I think we can say we're beyond the 2 to 3 debate and we're just in modern Python land.
I always thought it was funny. Your guys' on the Python Bytes podcast of the death clock.
Yes.
Kind of paying attention to that. That's about when I started, was when you guys started to ramp that up. And I was like, oh, wow. Okay.
See, is it Python? It's not Python clock. It's org maybe. Let's see.
Is this still there?
Yes, it's still there. pythonclock.org, but it is ticked down to 0. So yeah, okay. It's still there. And I think we're past it. The one thing that I wish we could have seen, we're supposed to have PyCon back in April, right?
Yes.
That was the first PyCon after the official retirement of Python 2. And I was hoping for like a big celebration with Guido, the core developers and whatnot. And like a big, just a community acknowledgement of like, wow, it took 8 years, but here we are on the other side of this. How amazing. And, we just didn't get that opportunity. But I think I don't hear people talking about it very much these days. So it seems like we're in a really good place. So that's one of the big things from that whole ecosystem. I think that's the biggest, is we're beyond the 2 to 3.
Wow. Yeah. I mean, I can imagine that those are a lot of the conversations maybe early on. We're still sort of struggling between both things, or that whole transition of, okay, we got to get this code base moved forward. I know I had Wukas Longa on to talk about his recent PyCon talk, but I know you've talked to him before about some of the stuff too of what was happening at Facebook and them moving their code base over. And
Yeah, absolutely. He's a big proponent of the type hints, which also come in Python 3, right?
yeah,
Not even early Python 3, but later Python 3. But yeah, over at Facebook and specifically Instagram, I think was his area. They did a lot of work to add type hints and MyPy type checking, and they found that they've discovered and removed a bunch of bugs and cool stuff like that.
yeah, all that stuff's, for being a dynamic language, it's a really great way to kind of help with, testing and moving everything forward. And I'm a big proponent of it, even though I'm kind of new.
Yeah.
It's one of the first things that I wanted to learn. And that kind of leads me to us talking about, just the whole idea that you have a similar path of the starting point that I did. That's how I found your podcast, was that I'm one of those people that I really like to really immerse myself into this kind of element. And I felt like, okay, what are all the Python books, and that's how I found Dan, and what are other resources. And so I found your podcasts, and then kind of going from there. Is that a similar experience that you had?
It is. Yeah. I think there's just so many resources out there now. There were a lot of resources then, of course. There was Stack Overflow and there was YouTube and stuff, but it seems like there's a lot more people who are taking this idea of content creation for Python developers and people who need to learn and get better at Python, and they've taken it, to the next level. Like Dan and Real Python and all, you guys definitely are in there. I ended up making that my full-time job. Thinking of some of the folks on YouTube, Syntax, Corey, those guys, right? They're really focused on it. And even if you look at the more traditional training companies, some of the big online catalog places and whatnot, they've all started to embrace Python much more. And I also think one of the big stories kind of in parallel with that is the embrace on the enterprise corporate, like the big corporate side of embracing Python, right? Like Python used to feel much more like the rebels, like these are the independents and they're using this funky open source language. But when you put on the tie and the suit and you go down to the main company, it was Java, it was .NET, it was these more traditional languages with support contracts from Oracle or from Microsoft or something like that.
Right.
And now, you look at Microsoft and they're all about Python and things like that, right? It's a different world. It's such a good world though.
Yeah. One of the questions I used to ask as like a weekly question that I thought was really clever, but then I kept getting the same answer was, what is something that you thought you knew about Python, but you were wrong about it? And the answer that I would get most commonly was, oh, I thought it was a scripting language. Mm-hmm. And after about 5 or 6 of those, I was like, okay, maybe this isn't the best. Maybe I need to rephrase the question or figure out some other way around it. But I think that I guess I don't want to call them, old timers, the people that have been doing Python, somebody like Brett Slacken, who's working at Google, and some of the people from Microsoft and so forth. I think you're right. That whole Rebel Alliance kind of idea that they're coming in and using Python in these new ways. But initially, Python was thought of as it's just a scripting tool, that I can use to write these simple programs. But, the evolution is pretty large.
Well, that's a really interesting way of framing it. It's a scripting language, or people ask, what's your favorite scripting language? Is it Bash or Python? And to me, it's just, it's like seeing a little tiny sliver of an iceberg or the periscope of a submarine and going, oh, look,
right.
What kind of stick do you like to drive around? Like, well, that technically is a driving stick, but if you understood more of it, there's a lot more going on there.
Yeah, so much more.
Yeah, there's just so much more. And so whenever I talk about Python programming, or in my courses when I'm presenting a program, I don't say, let's go use this script. I always refer to it as, we're going to build an application.
Yeah.
And I also think that gives you a different mindset. If I'm building a script, I'm going to have one file and I'm going to cram all the stuff into it. And sure, it's 2,000 lines long in the end, but whatever, it's my script, right? If you're building an application, you think about the parts of it and the layers and how you break it apart. And here's this part that accesses the email API, and that's 100 lines of code over in this section. And then here's the part that handles authentication, and it's another. And I think it gives you entirely different mindset around what you build and what is possible, what expectations there are of you as a developer to build it correctly with tests and patterns and factoring correctly and whatnot. And so to me, it's really interesting because it sort of starts you down like this little path that sort of diverges, but in the end, it's like massively diverged where you end up.
Yeah, I think it leads to something that we were discussing earlier, the idea of Python being this full spectrum language too.
Yes.
And do you want to dive into that?
Yeah, I would love to dive into that. So I just talked about how Python is great and you can do all these like real CS things, right? It has generators, classes, all the high-end Lambda functions, functional program, all the high-end CS ideas. But I don't think that that's why Python is so popular. I think it's popular because it's this thing I call a full spectrum language. And if you think of programming languages on a spectrum of beginner friendly, expert developer friendly, or pro application friendly, maybe also put on that spectrum somewhere like productivity or something.
Okay.
There's a lot of languages that live on the left hand of that spectrum where beginners are happy, right? That could be sort of funky compute environments like MATLAB. It could be VB, like Visual Basic VB, where it's really incredibly easy to get started and get something up and going.
Yeah.
The problem is you can't take those things to the other end of the spectrum, right? Nobody would say, let's go build YouTube in VB, or let's take our MATLAB program and turn that into a true analytics API, right? You're like, okay, we're done with this language. We have to drop it and switch to a quote grown-up language, right? Where we do professional stuff. And that's a challenge, right? Like if you learn the one thing, it's hard to make that transition in the same way or be happy making that transition.
Yeah.
But Python is special because more than almost any other language I know, you can be very effective with Python with a very partial understanding of what the language is or what it does, or even the concepts in it. So for example, imagine I'm a biologist and I have a research lab. I've got a bunch of data. I need to transform it and then group it. And then I want to do a little analysis on it and then graph it. And maybe there's a library that understands the file format. I know I could use like Altair to graph it, and that would be great. I could go and write a Python script, probably is what they would think of it as, that has like 5 or 6 lines, like load data file, make transformation, do grouping, show graph, right? And they don't even really know about like the dunder name equals dunder main. They don't know about functions or classes. And yet they built something that if they show to somebody, they'll be like, wow, that looks pretty awesome. I didn't know you programmed. How did you do that? Right? And they never think of themselves as a programmer. So that's like the way left beginner side of that thing. But then over time, it grows and you need more to do a little bit more. Like, well, what if I want to pass different information and reuse the same computation? Well, now you need a function. Well, let's learn about functions. And then, I want to share this. Let me learn about packages. And it just slowly grows until a couple of years later, that biologist is like, I'm kind of a programmer. How did this happen? Right?
Right. Yeah, totally.
And so you make your way along, but there's no point where it goes, I have to be a programmer. Let me go learn C++ so I can do this for real. Like you just keep going with Python. I was just reading an article today that the folks in a UK university took the data from the Kepler Space Telescope that looks for exoplanets.
Okay.
And they used machine learning and AI to find like 50 additional planets in the data that nobody discovered. And
wow.
That's still Python, right? That's not like, well, they switched to a real language. It goes all the way to the state of the art scientific computing, or like YouTube is written in Python, which is processing 1 million requests a second.
Right.
1 million requests a second in Python, right? And Instagram, we already spoke about them. Like there's just so many high-end things. So when I say it's a full spectrum language, it's like really beginner friendly as much as any language you can imagine. And yet you don't have to abandon it to get to the professional apps that you might want, right? You can go use Flask or Fast API or TensorFlow, whatever. You just keep going.
Yeah, just keep on growing. That's kind of where I started with it, was trying to be a problem solver within the programming space and working with these small businesses. And the thing that excited me very quickly with it was, as I did my immersion and trying to find books and so forth, I ended up seeing all of those paths. I was working in sort of a data science sort of shop inside of a bank, but I was the one being requested to build tools, to build things that I could stand up, and everything was there. I wasn't needing to necessarily leverage all these additional other languages to stand things up. I could do almost all of it within Python, which was very exciting to me.
Yeah, I think the opportunities just keep revealing themselves as you get farther and further in.
Yeah.
Right? You solve one problem with a little bit of automation, and then you're like, but this other thing, now that that's not the thing that I do all the time, there's this other thing that's constantly bugging me. So how do I automate that? It's just these little steps. If you keep taking those steps, you end up in a place where you're just so different from your colleagues who are not doing that kind of stuff. Even if you're not a programmer. If you're a programmer, a different story. But if you're not a programmer, but you adopt these little things like you're describing here, it's night and day what you can accomplish, right? You're like, oh, well, it'd be great if we could get that data off that website, but it's just in the web page, and then it's all in the HTML. And then if we could process it and graph it, but like Excel doesn't, like I can't Excel that, right?
Right.
And
not easily.
it's like, well, a little web scraping, a little beautiful soup, a little bit of pandas, and we're done. You know what I mean? It's just like so different. So yeah.
Yeah, one of the things that I think that has led to another thing that we were kind of discussing initially was like talking about, the growth of Python. And that's something that I don't have as much history with, but I think you've probably seen, just even with the growth of your podcast and the growth of the audience that you've been seeing. You want to talk a little bit about like, what are the areas of growth that you've seen with Python in the last 5 years?
Yeah, sure. So the way I think about the Python space, I don't know how accurate this is, but this is my mental model, is there are 3 equal sized slices of the Python ecosystem. We've got the web developers. These are the most old school of us, and I count myself amongst them.
Right.
Right. This is one of the first main areas that Python really was shining. Then we have the data scientists who are doing all variety of stuff. And then we have other. And I think that other is also a third, is probably about a third of the size. And that's just everything. It's those people that are automating Excel, those people that are doing a little bit of web scraping. It's the DevOps. There's just so many things. If you look at the growth of Python, I think it's grown a little bit for the web folks. It's definitely gotten better for the web folks. Like Fast API, Flask is really coming on strong. There's just so many cool things happening on the website. There's so many web frameworks that people are creating and iterating and coming up with something beyond that.
They're so much more mature too.
Yeah.
As we kind of look at them, and like just things with like what Django, just in my time of jumping into it, went from 1.11 to 2 to now 3, and that's like in a year and a half or 2 years at most. And it's just amazing all the things that they've added and the maturity level of what those tools offer.
Yeah, absolutely. I think a lot of the recent innovation has to do with the dropping of Python 2, by the way. Like soon as you say, we're going to embrace the Python 3 features, well, all the older frameworks, they didn't.
Right.
They weren't built around the assumptions that you had those things there, right? Like they weren't built around the assumption, like, of course you could do async and await. Why wouldn't you? Or of course you could have type information, and that type information means something, like tools like Pydantic or Fast API and so on. All super interesting stuff there. So there's, in terms of the growth, like that's a vibrant area, and I think it is growing. But if you look at where the real growth came from, I believe it's from that scenario, that biologist I described. It's people who don't even consider themselves Python developers, but they realize I can probably solve this problem with like 10 lines of Python.
Yeah.
And then they iterate, they make it a little bit better, they have some success, and they just keep growing, and they kind of get sucked into the gravity well of Python. And I mean that in a good way, right? Like they're like, oh, I could also use this other library. Oh, and now I've learned a little bit more about the language. I can write a slightly better program. And they just it like pulls them into the whole world of programming altogether. And so I think there's many, many people out there who don't, or at least initially did not consider themselves to be developers, but then they did a little bit of computational programming, and over time they sort of mastered it. They become very powerful. It became very powerful in their tool set, and now they're doing daily Jupyter stuff.
Yeah.
Right. If you look at some of the data computation conferences, it used to be like, oh, we're using Julia and R. And around 2012, a lot of that stuff switched to Python and Jupyter. And if you look at the Stack Overflow trends, guess what? There's a strong inflection point right around the maturing of all the Python data science tool sets. It just like there's a strong curve that goes up right there. And it's like, those are the same people coming over right there.
Yeah. That stuff is so exciting to me. I really love the data visualization area and, all the different packages there. And at the same time I was starting to learn Python, I was learning some of R, and I could definitely see, partly what you were talking about before. R is really great at a handful of different things and is definitely a tool that's useful in data science, but it's not really a full spectrum thing,
Yeah, it's super specialized. And when you're doing that specialized thing, it makes a lot of sense. But if you move beyond it, then it gets really hard.
Yeah.
Yeah, absolutely.
So I was thinking, over the 5 years of your podcast, what were some of the stories that you could think of that kind of like maybe show off some of these trends of the development of Python and the development of the community over this, time period?
Yeah. So I'll highlight a couple for you.
Okay, cool.
One of the ones that I thought was really interesting right in the early days was talk to Mahmoud Hashemi, who's been on the show a couple of times. He's done all sorts of interesting stuff. And he, when I looked at the Python space, all the conversations in the energy, especially 5-6 years ago, was, here's this small website, or here's a Silicon Valley tech startup that's choosing Python for this or that. But you look at the traditional corporate, S&P 500 type companies, they were still doing Java and .NET and whatnot. And so I thought it was really interesting to talk to Mahmoud about how Python is being used in the enterprise. And there's just so many cool success stories, I guess you would call them. And I think they're interesting because they break a lot of misconceptions. So for example, one of the things we talked about was over at PayPal, they've got some APIs, a bunch of APIs, microservices and whatnot. And one of the things they were doing is there's a Python API whose job it was to tell all the different parts of PayPal and the apps and whatnot, here's like an exchange rate, or here's how much this fee for this type of transaction is going to be. You can imagine that gets called a lot.
Yeah.
That thing was written in Python and it gets called like billions of times a day.
Wow.
Which is insane. It has like, a couple of millisecond response times. And there's all sorts of interesting things they had to do to make that happen. Like it doesn't exchange XML or JSON. It exchanges some like tight little binary format that requires like little parsing and stuff like that. But just those stories of, it's being used in these major ways. And, here's some concrete examples. I think especially in that space, those folks, they need to see success in similar spaces before they're willing to adopt something, right? Like if everyone else, imagine their car company, everyone else is using Java, we're probably going to use Java because
right,
we're not a tech company. We just need the car to drive and update itself, right? Imagine that if a car could actually do that besides Tesla. Anyway,
Right.
they could use some lessons, I guess. But, as you see this success, you're like, oh, okay, well, this other company like mine, they're getting ahead of us and they're using Python. Maybe we should, take a chance. And I think that telling these stories is really important, not just to say, oh, here's a cool feature you could use, but here's some company like you doing, being successful with Python is much more likely to drive the adoption of it.
Yeah, I think that it's a double-edged sword there in the sense that you have to have, people that are familiar with the language, but then you also have to have these sort of shining beacons that say, hey, this is possible, and you can share that with, here's kind of an off example analogy in the sense that I was using these tools at a school I was working at, was for recording engineers. And there's this tool that I got introduced to from Apple called MainStage, and nobody was using it. And I thought, okay, well, why is there like so little adoption of this MainStage tool? And it took me being able to say, okay, here you go. Here's an article that's showing an entire live show being done with this software tool by 9 Inch Nails. And so,
oh, wow. Okay.
So suddenly like people are like, oh, so this isn't like a toy, this isn't like a joke. This is like people are, using this thing as a digital mixer, as a way to do virtual instruments, to do, routing and all this live performance stuff. And then being able to hit a button and change the entire set to a whole nother song with all new sounds and different mixes. And it just combines all this technology through using a computer. And that was my goal as I was teaching, digital audio, which was always kind of this battle for people that were, wanting to like go sit behind this huge SSL massive recording desk,
right?
And look like they're going to be, famous doing that sort of stuff. And it's like, no, you really should understand computers because that's really the wave of where this stuff was at. This is years ago when I was like, trying to be this person evangelizing that kind of stuff. And I can imagine that's an experience that people have with Python very often. It was like, you have to have that thing to show someone to say, hey, this is amazing. And, like you've been saying, Instagram and Facebook and even these, like that PayPal thing is, again, like, hey, APIs can be written in Python and it's actually really powerful what we can be doing with it. And what's nice is it's also approachable and readable at the same time.
Another aspect of all that is if you look at like the Stack Overflow developer surveys, which is a great source of like general developer community trends and interests. If you go to the section on most loved and most wanted programming languages, Python is either number one or it is right there.
There you go.
And so if these big companies, if they think about, oh, all of our employees keep leaving, we got to hire new ones. I don't know why they don't like to work in this restricted environment where it's like half COBOL, half Java. Like surprised they're finding more interesting stuff to do. If you can work in languages that developers really want to work in, you can get the best people to come work for you because you can say, you don't have to do Python on the side and C++ during the day. No, you can just work in what you want to work in, right? Like for me personally, I will not work in another place if I had to go get a job
right
using a technology that is not one that I really care about unless I have to, right? But if there's another option, even if it pays less, it's a good chance that I would still go do that because all day long I would be happy writing code in what I want.
Yeah. Yeah, no, and it's what's kind of fun about it too is like, kind of going a little bit into the community thing too of like the people that I've met that are programmers in it. And when I was doing my immersion and trying to like learn all the stuff that's there, the community in, kind of in general was sort of, I don't know, positive leaning and sort of like willing to engage. I was trying to, at the same time, maybe, I don't know, 3 years, just a little bit before I started into Python, I kind of dove a little bit into JavaScript and I had a real hard time like ever clicking with any of the things that were happening. And it felt very like, it's just, maybe I just didn't find the right group of people, but it felt kind of exclusionary in certain ways of like, oh, well, you should be using this tool. Why are you even bothering with that tool? That was last week.
Yeah.
It's like,
that's exactly my feeling about JavaScript as well. Like, I feel like there's just no sustained thing, right? I feel like it's always, okay, this is fine. Our very next goal will be to try to replace this with something better, which on one hand, I admire that, right? It's great to keep pushing things forward, but on the other, it's one thing to say as a developer, you're going to have to keep learning, obviously. And that's a great aspect to being a developer, but it's also kind of frustrating to say, like, every 6 months, the thing that you thought was awesome and important is not just slightly less, the top interesting thing. It's looked down upon, right? It's like, oh, you're still using that? Man, Vue was so 2019. What are you doing? And I'm like, dude, I'm still writing a Vue. I don't care. Or whatever, right? And so I also get that feeling that it feels like there's just an impatience or something a little bit in that community.
Yeah.
Where Python is also changing quick, but I don't feel like it has that same aspect. It's like a little more appreciation of where we come from.
Yeah, there's some growing pains. Obviously, you've been through that with the whole 2 to 3 transition. And even with the newer revisions coming out, there's grumbling about like, okay, why is there this focus on this? Why is there this focus on that? But, I feel across the board, partly why I was super excited to get into this community was the wanting to share and wanting to grow and wanting to, I don't know, to see success in everyone else. It felt less, I don't know, it felt more cooperative than competitive.
Yeah. Yeah, I really agree. I think it's also interesting. I talked about the rebels, right?
Yeah.
In a positive way. I think, you talk to some of the folks, like the guys over at Anaconda Inc. and whatnot, and it's interesting that there's all these corporate folks coming in who have had a different relationship with technology. So if you're in open source, you kind of know, like, we're all in this together, we're all rowing. Let's go. And, you can't just go to a project and say, you have to do this for me, because it's like, right, this is their project. They love it. And if possibly, if you can convince them it's a good idea, then it'll be there. But if you come from, say, working with Java and Oracle, and you've had a service level agreement that if anything is not right, these are the people you call and you tell them how it's not right, and you get them to fix it. Right. If you're an enterprise developer who's not like super passionate and it's just your job, 9 to 5, you do your job and you go home, you don't really love like the technology of it, but that's what you do. And somebody comes to you and says, now you've got to learn this new language, you got to learn this new technology and make it work over here. And when it doesn't, you get just frustrated, right? You're like, well, there's no one here to help me. Like, how do I go and like file a frustrated issue on a GitHub repository and have them fix it, when really it's their spare time contribution to the world? Like, it's not their responsibility necessarily to fix that problem.
Oh, yeah.
So I think there's going to be an interesting tension as Python becomes more popular and more adopted. And in the world where those deadlines matter, people are used to having like a company there to support them. What's going to happen when it's not?
So do you feel that, this growth in enterprise, do you think there's a reciprocal aspect of the enterprise giving back to Python? I mean, not only, with users and people adopting it, but, financially and other ways of support. Have you seen that?
I've seen it somewhat. I would like to see it a lot more.
Yeah.
I find it nearly unacceptable that a bank can have their core trading engine and their fundamental internals running on Python, and they don't contribute 100 million a year back to Python or something like that. And there's like 2 of the probably top 5 largest banks in the United States are running on Python in major ways. Like, one of them has 35 million lines of Python code. Another one has, I don't know how many lines of code, but 5,000 Python developers. Like, that's a lot of Python.
Wow.
Just from a personal well-being, you think like, we got to make sure that this technology is stable and on point, because we're so built upon it. Right. And I just think we in the Python community need to find the right way for those organizations to see the value in supporting the community directly. There's things that are really expensive in the Python space, like the bandwidth bill for PyPI, as in pip install,
Yeah.
is something like $40,000 a month. But there's also so many things we could do if those companies stepped up. And not to just single out banks, but those banks clearly have a lot of money and a lot of reason to support it, right? But if those companies just said, you know what, this is really important to us, we're going to contribute, $1 million a year to support this organization. You don't need many organizations like that to support the Python space before it transforms how stable and how much it can accomplish. Like, for example, the PyCon conferences are the primary way in which the PSF is funded.
Yeah.
That seems crazy to me. It seems like if all of they get so broadly used and consumed, it seems like that there could be more. But yeah. So I do see them doing it. I do see like the tech companies doing a little bit more.
Yeah.
But I think that these more mainstream companies, there's just not a mechanism like a donate or a sponsor with no return value. It's just not the world that they live in. So I don't know what the right answer is, but I hope that we can find something to capture that value.
One of the things that, having worked in the bank, there's these acts, if you will, that are designed inside of the companies that the bank has to give back to the community, that they're based in.
Yeah.
That's part of a financial thing. And it's, like somewhat regulated. And I don't know if, that's really maybe overstepping the bounds of this, but something like that where it can be seen as affecting a community or this larger community of developers and so forth, so that these people that are sometimes it's literally their weekends, what have you, to continue to building on the support there. I don't know how to change the focus, but it's something I'm very interested in, and I definitely want to bring in some people from the the Python organization and talk a little more about like, okay, well, what are ideas and plans and things like that. I'm having the group of people from PIP.
Yeah.
Hopefully talk to them soon about, I know they were talked on Brian's podcast recently. And so I know they're trying to talk about enhancements there, but I want to also maybe talk to them a little bit. Like you said, the hosting bill sounds crazy.
Yeah. So I believe Fastly, the CDN is donating. So all the stuff is like donated, right?
Yeah.
Like the hosting bill for pypi.org is, I believe, covered. The bandwidth bill for Fastly is covered. But imagine what happens if they decide that they no longer want to donate that much bandwidth, right?
Yeah.
it's everything's in a bad place all of a sudden. And if you can't pip install anything, your automated deploy to Kubernetes at your bank is going to stop working. Right. And all of a sudden someone's going to pay attention when, the bank site, the trading systems go down or whatever.
Right. Definitely. This week, I want to shine a spotlight on another real Python video course. It covers a topic we touch on during this week's episode about how to wrangle Microsoft Excel files using Python. It's titled Editing Excel Spreadsheets in Python with OpenPyXL. The course is based on a real Python article by Pedro Preguiro. In the course, instructor Joe Tatusco takes you through how to read Excel spreadsheets and iterate through the data, manipulate spreadsheet data using Python data structures, create simple and more complex spreadsheets, format workbooks using styles, filters, and conditional formatting, enhancing spreadsheets by adding images and charts. I think it's a worthy investment of your time to learn how to use Python to manage and automate processes with these extremely common spreadsheet files and workbooks. I think it could save you and your office tons of time and frustration. And like most of the video courses on Real Python, the course is broken into easily consumable sections, and you get code examples for the techniques shown. And as one of the newest courses on the site, it already has transcripts with closed captions ready to go. Check out the video course. You can find a link in the show notes, or you can find it using the newly enhanced search tool on realpython.com. So what are some other stories you've seen of changes and growth in the Python space?
Let me tell you one that kind of highlights this full spectrum thing.
Yeah.
That I talked to. I've seen that a lot. A lot of folks who come on and they're not, they're just doing some kind of science, but it turns out that Python is really good for them. This is a show that I mention a lot because it really breaks a lot of paradigms. And it's one of these things that like you can look at and you say, if that guy can do that, I'm fully underperforming and I should be able to just do so much more. Why? I just need to think bigger. I got this message from a guy named Cornelius Van Lit. Cornelius is a PhD researcher who's also a monk, very interesting guy, in the Netherlands. And he works at a university doing research on medieval philosophy in the Islamic world. So like 980 type of time frame, right?
Yeah.
So he studies humanities, works with a lot of folks that are kind of in the library science side of things. That doesn't sound like a high-end programming sort of role. And how are you going to apply programming to this? So he said, hey, I want to talk about Python, and I got this cool story to share. I'm like, okay, you got to convince me somehow that this is going to work, right?
Right.
But I'm so glad I had him on because he is using Python and OpenCV and computer vision to understand these like calligraphy manuscripts from 1,000 years ago. And there's certain things you can learn. Like if you look at the shape in which the scrolls are folded, there was like patterns at different time frames. So if it was an 800 AD scroll, it might have this type of folding. And if it was a 1200 time frame scroll, it would have a different way of being folded. If you were writing on it, it would have this ornate stamp that's like your signature, but it's a picture in a really complicated way that's not just your name and whatnot. And he's using OpenCV to identify those stamps, create a graph database to look at the collaboration relationships across different philosophers, to look at that folding pattern, to automatically classify what time frame the work was performed in.
Yeah.
All of those kinds of things. And he's just taken something that seems like it's not super understandable by computers. There's not like really, it's not like, well, we're doing finance, so Excel and then a little bit more, right? It's really far away from something that looks like easily understandable. It's not even written in computer form. It's like calligraphy. And he's applying these cool technologies to it and just being able to answer questions, like 1,000 times bigger than the other people who studied this stuff.
That's pretty cool. I mean, that's something I don't have the CS background. Again, I've kind of bounced around in lots of different languages, and that idea of graph theory, it would be interesting that he would sort of land into it in the sense that he has this subject domain of knowing these are particular philosophers, and I'm guessing the people that are doing the writings, they may be somewhat separate. Somebody's actually taking the dictation and, writing it down or translating it and so forth. But to see the relationships across, the time using all those different markings and the images that he's able to gather, that's pretty cool.
Yeah, it's really cool. And now he's a big proponent going around giving talks saying, all of you people who think you should run away from computers and they're wrecking books and they're wrecking all this long form reading, and like, you need to embrace this now, because those of you who do are going to just leave everyone else in the dust.
Yeah, just the amount of time that it would potentially speed up for him. When did you talk to him?
That was in 2019, almost exactly a year ago. That was episode 230.
Okay.
So he's just such an interesting guy. And I think it really tells the story of, here's somebody who has a question. They can take a little bit of Python and they can be much more effective, and not in little steps, but in big steps, right? Like, here's the thing, like, I wouldn't think, oh, I can solve that problem with computer vision. You know what I mean? Like,
right.
I just don't usually think, oh, I can apply this crazy thing, or I could create an artificial intelligence that's going to go do that. Like, I'm like more like, I can probably create an API or something,
Right.
So even for me, I don't know that I would have thought that big to do it. But the fact that there's like this grand vision plus a little bit of code knowledge, right? Because it sounds like it would take a computer science PhD in like image recognition sort of work, but it doesn't. And so that's why I really like the story, because it reminds people that they can think bigger and do these amazing things, and they probably can be successful doing it.
Yeah, it's totally sort of inspiring in a lot of ways, the idea of using these tools to to do the problem solving, which is always things that I kind of come back to, is that's really what we all are, is this person might have had a form of frustration and wanted to sand off some of these hard edges and definitely speed up what he's doing, but also potentially uncovering, there's stuff that the computer vision can see that, somebody's not going to see themselves, and be able to like have the computer remember things for you and be able to spot the relations.
Yeah. There's a lot of interesting stories around that kind of stuff with like machine learning, and oftentimes that means Python. One other thing that we did is we had folks on about how machine learning is being used at, I think it was CERN, but also at Stanford.
Okay.
Yeah, they were using machine learning to look at the particle traces out of the Large Hadron Collider and trying to understand when they're discovering like Higgs boson type things, or they're discovering a new quark that they didn't know about, or things like that. Really interesting stuff that people are like applying these amazing ideas to. It seems like there's just no end to these stories. They just keep coming,
That's cool. How are you finding these types of guests? Are a lot of them reaching out to you? Are you like kind of reaching out to the community and asking for the voices? How's that changed for you over the last 5 years?
In the very early stage, it was, here are 5 things that I know about Python that are interesting to me, and I know who's behind it. So I'm going to reach out to them, I'm going to reach out to Mike Bayer from SQL Alchemy, and we'll talk about SQL Alchemy because that sounds fun, and reach out to Chris from Pyramid Web Framework and talk to him about that, and so on. And pretty soon I ran out of ideas that I knew about or who to reach. In the early days, it was a lot of, okay, well, what else is out there that I don't know about but looks interesting? And it was a lot of like seeking out stuff. And now it's just a never-ending inbound supply of like, hey, Michael, that was cool. Did you know about these other 3 things that are amazing? and so on. Yeah.
That's cool.
Yeah, that Large Hadron Collider article episode is 144 over at Talk Python, where I had Michaela Paganini, Michael Kagan, and Matthew Fikert, and they're all talking about, there's the amount of data that the Large Hadron Collider generates. It's one of those things that just boggles the mind. Like, you can't write it to disk sort of fast enough. There's not enough disks to put it in.
Right.
So there's like all these layers of, you have to process it here and filter it down to only the interesting stuff. And then you take the interesting stuff and you feed it to like a C++ layer that like can condense it and pull some stuff out. Then you feed it off to a Python layer to analyze it. There's just, there's some cool videos about how much data flows through those systems. Also, another interesting thing, I don't know if I've done a dedicated show on it. I would like to. I've tried to. I don't know. I don't think I was successful. Definitely not as a main topic.
Yeah.
Is the use of Python in astronomy.
Okay. And,
controlling telescopes in terms of processing the data that comes out of the telescopes. Like I said, there's folks who are using machine learning to find the exoplanets.
Yeah.
That's just awesome,
Yeah, totally. So one of the notes that I saw you put on our document here was about async. And I know that was a conversation that kind of kept going back and forth for a while. And I know you even created your own teaching resources on async. But I feel like it's like one of those topics that is very interesting in the Python space.
There's a couple of things in the Python space that I feel like they haven't really been supported, or they're really so hard to do that people don't see them as part of the spectrum of tools that they have available to them. Let me give you a side example before we talk directly about that. When was the last time somebody gave you an application that you could download from an app store, or like an installer that you could put onto your computer, into your dock or your taskbar, and double click it, and it had a window that was written with Python? Basically never, right? There's a couple examples, but almost never.
Yeah.
And the reason is it's hard to do, right? But when I talk to people, I'll say, Python is really missing out on this desktop application thing, right? A lot of us sit down and work at computers, and the CLI is great, but GUI apps, they're still really important to a lot of people, especially outside the developer space.
Yep.
And they're like, I never even really build desktop apps. So I don't really know why I need this feature in Python. The reason you don't build desktop apps is because it's nearly impossible. So of course, like it's this chicken and egg thing. Like there's no energy being put into making that. Sorry, take that back. There's little energy as a community being put into making that like a super easy thing to do, because so it's like so far off the radar that it's something that people even want to do. But if it was super easy, you can bet there'd be a bunch of Python desktop apps, right?
I wonder if there is some of that where, we spoke about JavaScript briefly, but the whole idea that, when I was getting back into programming and delving into this world, that there was this whole idea of like front end and back end and literally like they were like considered different skill sets. Like, oh, as a back end person, I don't have to worry about design.
Right. I don't exactly.
I don't have to worry about user interface and so forth. But in the end, again, as a problem solver, yeah, you do. You kind of do. And I know it requires different skills, but I think you're right that there needs to be.
Wouldn't that be great? I mean, if there was a framework with a visual draggy droppy thing, like traditional Visual Basic from the 90s for Python, that would be insane.
Right.
People would build all sorts of apps like that. Maybe not traditional web developers, but you could bet that there's some like data science folks or whatever that would like to share their projects with people, and they would take that up. So I kind of just as a proof of concept, I created this little like menu bar app recently.
Yeah.
And you can do it. I've got a little app now on GitHub that you can go and download a zip file and drop it into your applications on your Mac and run it. And you wouldn't know it's Python. It could just as well have been Objective-C or Swift. And so it's possible, but it's not common. Anyway, I feel like async is like that. Like Python has been so separated from having great parallel computation capabilities because of the GIL and things like that, that just the desire to say, yes, I need async in this place, or the experience of having success with it previously is not as common in the Python space as it is in, say, C++ or C# or something like that.
So if we could take a digression just for a second, because I feel like it gets mentioned a lot, and I always get a little confused sometimes by these topics of like, okay, well, how is the Python GIL, the global interpreter lock, how is it stopping things?
How is it the problem? Sure.
Yeah.
So when I first learned Python and tried to understand this async stuff, I thought the GIL was a parallel thing, a multi-threaded thing. And technically it is, but the point of the GIL is to make non-parallel Python code run better. Okay, so the way the Python memory is managed in Python is every object is a PyObject instance, a pointer to a PyObject thing, and part of every PyObject is a field that says how many variables refer to this, right? The reference count. And so soon as things stop referring to that object, it's deleted, right? In memory sense. So you have two choices. If you have true parallelism in Python, every time a variable is assigned or unassigned from one of these PyObject pointers, which could be simple things like numbers even, then you were at risk of a race condition around that object, right?
Like things wanting to get to it or update it.
Right. If like in one thread, one is unassigning, right, as another is assigning, even like variable plus equals 1 is not thread safe because it's like read value.
Okay.
And then change value. And if they both go read, two threads go read, and then increment, you're going to end up with a +1 instead of a +2 situation. And so that reference counting section without the GIL would have to be thread locked. And if it's thread locked, then you have to, all of a sudden, incrementing a number goes to take a thread lock, block out all the other threads, increment the number, unblock all the threads. Like it's much more expensive to do non-parallel regular Python. Like its core memory management system becomes expensive because of that thread locking. So that what they said is, well, let's just let only one line of Python run at a time. That way only one variable assignment or unassignment could be happening, and we don't need thread locks. So the GIL is really there to optimize the serial version of reference counting.
Okay.
Yeah. But because it's so baked in, It's really tricky. So Eric Snow is actually working on, I don't remember the PEP number, but something called sub interpreters, which, I'm super excited.
Yeah, this has been mentioned a couple times. That's when I said what. Yeah, Brett Cannon was like, I asked him what he was excited about, and that was his. And then Anthony Shaw from Real Python, and that was his other thing he was super excited about too. So it's come up multiple times on the podcast.
Yeah, that's very exciting. And the reason that will work is you'll still have the GIL, and you'll still have reference counting, and you'll still have this race condition. But what they're going to do is going to say, if you want to have two threads, each thread can have its own interpreter and its own set of objects it manages, it cares about, and has access to. And one thread will not have direct access in a reference pointer style to the other object. And so within any given subinterpreter, there's only one thread, so the GIL doesn't have any issues. And if you want to exchange data, share data, there's like a data passing mechanism that is separate from the overall object reference counting. So that'll allow them to basically run, eight subinterpreters on an 8-core machine, if that's what you want.
Yeah.
Cool. That's exciting.
Is it still a ways out?
I believe a lot of the cleanup work, there's like a ton of global variables and shared stuff that have built up, as you can imagine, over like 25 years. And Eric's work was to like slowly bring these into ways that could be separated from each other. So a lot of that precursor work, I believe, is already done, but it hasn't manifested itself in the full end product yet. But they're making these architectural steps towards making that possible.
Okay. Awesome.
Yeah.
Hey there. I have a favor to ask. If you like the show, could you leave a review on Apple Podcasts? It would really help the show. Reviews and ratings are a great way for more people to learn about the show. And as the show grows, it's helping to attract more great guests, and I want to share even more of their stories and knowledge with you. Thanks. I really appreciate the help. That kind of took us away from talking about async.
Well, I mean, that's also definitely very much about async, but async is the idea. It's one of these things that has been really challenging. And so people are like, I don't really need to do that. But if it was super easy and you could all of a sudden make your program run 8 times faster, right, 16 times faster by basically doing no extra work. And what I mean is, if I have my MacBook here has 12 cores if you count hyperthreading.
Okay.
If I take a Python program and I put it in a while true, increment a number type of full, as hard as it can hit the CPU as it wants, my CPU usage on my computer goes to 9%. Or something like that. That's the max. Like, that is the upper bound of how much I can take advantage of it. And you're like, oh, that seems not so awesome. My gaming computer has got like 16 cores that are hyper-threaded or something ridiculous, right? How much of that can I take advantage of? Like 5%.
Yeah.
If I don't take async into account. So that's one side. And I think that matters to the data science side, the computational side. As a web developer, I don't care about that. It doesn't matter. If I was doing web development, I'm using MicroWhiskey or something like that, and it has multiple threads, and it's doing a lot of the parallelizing for me.
Under the hood, right? Kind of helping you not having to think.
Yeah,
about it.
Exactly. Yeah, it's already like, so. For example, on Talk Python training, we have that hosted in MicroWhiskey, and we have 8. So when it starts up, MicroWhiskey starts 8 worker processes.
Okay,
and those 8 worker processes are running 8 copies of the Python website. Those are 8 different GILs, right? A GIL is a per process, not per machine type of thing. So they're effectively doing what the subinterpreter thing is doing, just in a really like hard way, right? By doing like multiple processes.
Okay.
So it's on that level, it's in a pretty good spot. But what I do care about is somebody makes a request to me. I want to talk to the database and figure out who that is. Then I want to talk to the database again and figure out the stuff that they've got. And then I want to talk to an API to figure out where they're physically located. And then I want to talk to this other thing, maybe to place an order. I don't know, some random thing like that. The amount of time that my Python code is running might be less than a millisecond. The amount of time that whole process takes might be 100 milliseconds, right? If I could somehow say, there's a whole lot of time I'm doing nothing, process, go do other things, right? You could handle so many more requests. I mean, this is the foundation of the magic of Node.js, like this single threaded thing that can handle 100,000 concurrent connections. It's that idea that let it go do other stuff while it's waiting for a callback instead of a blocking call. And with async and await and async IO, like that's what you get in Python. And it's so easy to scale the waiting time. And a lot of the benchmarks or performance comparisons that come out, they try to scale stuff that's not the right thing, or they try to emphasize scenarios where, oh, what we're going to do is we're just going to hit this database super hard. So we're going to try to take this bunch of worker processes, and we're, instead of just doing one request, we're going to do 100 requests, and we're going to send that all against the same database. Well, the database is going to go like, I can only take like 10 at a time, and now I'm like done, right? Like,
right.
You're just pushing where the block is. But if you're talking to external things, right? External APIs, other things that you know, have a limit beyond what you do,
right?
Then all of a sudden you can basically completely replace that wait with doing other work. So I don't know. I think there's really interesting things. And one of the stories that I think this was great is this is from one of the Python Bytes listeners. We were talking about some of these libraries and some of these things, and even some of these debates about whether like you really get better performance with async or not. And he said, you know, I adopted one of these things you're doing. I really wish I remember the guy's name, but you know, if he hears this, thanks for sharing the story. And he said, I was doing this web scraping where we're pulling a bunch of stuff down, and it was taking like hours to run, and it was really slow. And so I switched it over to Async IO and AIO HTTP client and stuff like that, and then kicked it all off. And then my computer crashed.
Okay.
Why did your computer crash? It crashed because it got so much data back from the internet, it ran out of memory and crashed the program. Right? It was like, it had sent this like, hey, everybody give me like all 5,000 of you web servers, send me all of your data now.
Just broke the dam open.
Right? And it got it. Yeah, exactly. And I know there's a lot of debate about whether or not it's like really an advantage or not, but if it goes from hours to I got so much of a response that it crashed my computer, like 16 gigs wasn't enough RAM, like that's making a difference, right?
Yeah, totally.
So anyway, I love that story because it's just kind of like, it's so in your face, like, well, it was barely sipping on the straw and now it just ran out of memory, like, because it got it so quick. That's a huge difference. And since Python 3.5 and above, like the amount of difference you write in code is like incredibly small to make those changes. Instead of variable equals blocking call, it's variable equals await blocking call.
Yeah. And
that's about it. So it's really a straightforward thing you can adopt in the right situation. I just think a lot of people, kind of like the GUI story I told, I just think a lot of people it's not quite on their radar because it's been too far out or it's been kind of impractical or something for so long. And even though now it is practical, it's still just not something that in the community people are really doing as often as they could.
Yeah, it's a need of, not only educating people on what's possible with it in having those resources out there and showing examples of it. I keep seeing more talks, and I had, Lucas, that was why I had him on the show, was to talk about his async talk that he did with music, and the sequence that he built was a great example too, just like how to use async in this live music thing. And it was super cool.
Yeah.
As far as
that's a really cool example that matches with your background super well.
Yeah, it was fun. Yeah. So what have you been teaching lately? What are some of your new courses?
I've been thinking a little bit more about internals and stuff lately, and a little bit more data science. So the last course that I just released is Python memory management and techniques.
Okay.
Which has been really fun, and like diving into, I talked a little bit about the reference counting and the GIL, that kind of stuff. But, why does Python have both reference counting and a garbage collector? And how expensive is that garbage collector if it has to go over all the stuff that's already reference counted, and answering questions like that? Or, what are some really simple design patterns that you can use that will like make your code use 1/3 the memory as it did before, and it looks almost exactly the same.
Wow.
So there's just a bunch of really interesting things once you understand memory and understand exactly how the memory is working and how variable scopes and all that stuff works. Then you can start to think about, well, what are the language tweaks or design pattern tweaks I can take to make my code run faster with less memory and so on. So I've been really diving into that lately, and that's a lot of fun. We're also doing a course for trying to bring people over from the business side, from the dark side to Python, called Excel to Python. So take all the data.
There you go.
Take all the data science tools like pandas and whatnot and Jupyter, and show folks, like, if you wanted to do this in Python, here's how you do it. Sorry, you want to do this in Excel, here's how you do it in pandas. Or if you want to do this thing, or if you want to even read and write Excel files, here's how you do it, to like kind of bring it full circle. So that kind of stuff, it's been really fun.
Yeah, that's all that stuff. I think again helps really build the community on that level. Like the having worked even just a short time in banking, the prevalence of Excel and
that's right.
And even there, like the people not understanding really even the things that you could do with it. I joke that my wife's like this total Excel queen. She knows like so much about it. She wrote a entire cookbook in Excel. I'm like,
how impressive.
Why? I know. I'm like, why would you use that as a tool? It's like, that's the tool she knew, and she could just make it do anything. It was very impressive. Yeah. So I think that's a great way to get people in and excite them about, what they could be doing with Python and hopefully making things easier.
Yeah, absolutely. And, there's some really interesting examples. If you just like search for like the 12 biggest spreadsheet fails in history, or there's some really crazy ones. Like, there was a copy and paste error in Excel. So we had like a $100 million loss that year or something like that. So like Fidelity had to cancel like their end of year dividend because they had like a minus sign off, a minus versus a plus sign in an Excel sheet. MI5, the secret agency in Britain, they bugged.
Okay, MI5.
Yeah, MI5. They bugged 1,000 wrong phone numbers because of a formatting error. Like the number was supposed to start with like 000, but it dropped off the zeros, or I don't know, some weird. There's just all these really crazy examples of
it truncated them.
Yes, of just people tried to use it and it just wasn't quite right. And
it's not an integer.
Exactly. It's not a date. It's not a date. It's a number. What did you do?
That's where I started learning, just the importance of data. And my other big beginning was SQL, and so having to understand tables and formatting data and cleaning data and getting prepared. And it really prepared me for a lot of the conversations I've been having in the Python space, like what you're talking about of size of things and, using the right kind of container for the right kind of object and not, these objects that you can create in Python, just by default can be huge, and that's not going to be efficient.
Yeah. I'll give you an example from that memory course I was just telling you. Numbers in Python are not like numbers in a lot of programming languages. So a number in C++ might be a 4-byte integer that goes up to 4 billion or whatever, and it would be 4 bytes.
Right.
In Python, it has the number, but it also has all the PyObject stuff and the pointers and the variable to point at it and whatnot. It's 28 bytes for like one number. And the letter A is 50 bytes.
Wow.
Whereas in C, that would be 1 byte. It's literally a character like pointer. And so understanding if you store it this way or that, it's not just a little bit different. It could be 10 or 20 times different. And so one example is if you have a list of numbers and you just put them into a list, bracket thing, append, that's awesome. And it grows and it's super handy. But if you were to take the same numbers and put them into an array, like Python has a class called array, which stores homogeneous types instead of a bunch of different types. Like it'll store all integers or all shorts or all floats. That's 8 times less memory.
Yeah.
So if you had a bunch of numbers you got to load up, just changing the load, the type of array thing could be 8 times difference in how much memory is used.
So that talking about an object like the letter A.
Yeah.
It's because it's truly a string and it has all of the different methods that it can, you can apply to it.
And it's all the other stuff all the things to handle the most complex string that it potentially possibly could.
And it's just a letter A.
Right. There's no character class in Python versus like string. There's not like a C string versus a char type of thing. It's like they're all the same, which is also the magic of Python, right? It's so easy because you don't have to go, oh, is that integer too small? Like it doesn't matter. Integers can be as big as they want to be. Or is that string? How do I like encode the characters? Like generally you don't worry about that stuff.
Do you feel like we hit the majority of the things that you wanted to touch on in the big ideas section?
I do feel like we've hit a lot of them. I guess one more, let me just throw this out to your listeners and folks.
Yeah.
One of the things that surprised me when I started the podcast was I thought, who's going to listen to this show? The most dedicated Python developers out there, the ones that are probably like maintaining the libraries that I'm talking about and working on the language, not beginners. No, not beginners. Because like, why do they care about the internals of how Flask like handles this or whatever it is we're talking about? And what I learned over time is like at least half the people who are listening are really new to programming and Python.
Yeah.
And I found it amazing that they would say things like, oh, I listened to the show and for a month I didn't understand what you're saying. And I'm thinking like, wow, that's dedication, right? I would think you would not want to listen anymore, but they're really committed to learning Python and programming, and they treat the podcast as like language immersion. Like if I want to learn French, I'm going to move to Lyon. I'm going to live there for a year until I know French, right? And it's going to be super uncomfortable in the beginning, but at the end, I'll be having this great conversation, somewhat at least. And I just think that it's interesting to consider podcasting as the language equivalent of tech, like the tech equivalent of language immersion.
Yeah, I'm that guy. I didn't write to you, but
that's awesome.
But that was me like, 2.5 years ago. And I, of course, at that point there was this back catalog and I was like, all right, how far back do I want to go?
Yep.
And so, what's kind of neat is a lot of them, episode wise can be, evergreen in the sense that this is a topic that is going to be repeated and so forth. And, I'm hoping to try to create that evergreen content myself in the sense that,
yeah, it sounds like that you are. And I think that's really valuable because it's one thing to have, timely stuff, but it's another to capture these big moments and stories and just keep them around.
Yeah, totally. Yeah. Well, thanks for helping with my immersion.
You're welcome. And I really just wanted to bring that up because I know there's a lot of people out there, way more than it would seem initially, who are doing that. And I just want to like kind of say, hey, listeners, this works, it seems like, and you're welcome here and whatnot.
Yeah. And that's the other thing that was exciting about it too is just like, finding people that are out there and kind of going back to the idea of finding guests. Like, haven't really had anybody like flatly say no to like a request at this point.
Yeah,
it's been me trying to find what fits in the topics and find stuff that is interesting. So that's been the fun part of it. It's again kind of going back to the community thing, which has been really cool.
Yeah, it's a real honor to just be able to like spend 10 hours on something you're inspired about and learn about it. I always consider myself the first guest or the first listener of the show, right? Really.
Especially when you're editing it and so forth.
Yeah, that's a different level.
Yeah, totally. So I have a couple weekly questions that I ask of everybody. And the first one is, what are you excited about in the world of Python? You're so immersed in this world. Is there something that truly has got you excited?
Yeah. I'm excited about everything.
Yeah.
There's so much stuff out there. It's really inspiring to see kind of now that we've stepped beyond the 2 to 3 boundary.
Yeah.
All these different things going, well, if this new language and these new features like type annotations or async or whatever are what we can count on being there, well, now we can reimagine how things are working. So it's really hard for me to just, pick one thing, but the thing that I'm inspired about right now, I guess I'll give you 2 because I can't narrow it quite down. One is Fast API. I think Fast API is the business. I think there's so much interesting stuff around the way Fast API takes type annotations and model binding through Pydantic. And what I mean by that is you can have a class that has like type annotations from Pydantic, and you can say, here's an API method, and it takes like a user registration object. And then that thing will look at the inbound form post and say, okay, well, here's a name and that thing has a name. So it'll like fill out all the parts of the class, even with validation, like they had to enter their age and their age is converted to an integer. And if it can't be converted to an integer, automatically tell them that's the problem. And it just takes so much of that writing professional code, writing code that actually checks all the pieces that are there, that all the types are right, not just enough to get it to work, but the real stuff you got to write.
Yeah.
And it makes it super smooth. And then it wraps it up in a nice async and await enabled framework to just fly. And the next API project that I'm working on is definitely using Fast API.
What's it based on? Is there certain underpinnings?
Yeah, it's based on Starlet.
Oh, yeah.
Which is the foundation of API Star before and some other things. And UV Acorn, which is one of the async ASGI servers based on UV Loop, which is a faster async IO event loop implementation and stuff like that.
Cool. Yeah, that was something that right at the end that when I was talking to Wukas, who was mentioning those two things, that he wasn't using the built-in async. He was, which is kind of interesting to me too. That the idea that it's almost like the language is built that you could drop in these replacements, which is amazing to me for async.
Yeah, it is pretty amazing. Yeah, and it's like one line of code to switch to UV loop.
Yeah,
you go to like async io.set event loop, UV loop.loop or something like that. I mean, that's the whole thing. And now you've got a faster implementation.
Yeah, it's pretty cool.
Of async IO. Yeah.
Yeah. And he was talking about Starlet. And so I wanted to learn a little more about that too, which, again, uses those tools. So
yeah, Starlet looks cool. And it's cool that it's being used as the foundation of other frameworks as well now.
Yeah, great.
The other one is Unsync. So I think as much as I've had positive things to say about async and await in Python, one of the there's a couple of like really clumsy things that I just don't understand why there wasn't like one final layer put in place to make them easy and awesome. Like, for example, I would love to take and start an async operation and just let it go. Can't do that. Sorry.
Okay.
Can't do it. You can do it with threads, but with the other one, you've got to create the loop and let the loop run, but you still kind of got to keep the loop around. And like, there's all sorts of funky stuff like that. Or I sometimes want to use a thread because I'm working with a library that doesn't support async and await or async IO directly, but I also have this other one that does. Do I have to have a thread API and an async and await API and like do these two things together? Unsync will let you take threads, multiprocessing, and async and await, and it turns them all into the same API that uses the async and await keywords. So now you have not just one, but three types of multiprocessing, multi-threading concurrency in the best of the 4 possible options with this async and await. And then it automatically runs them all, the async IO ones, on a background thread that is just running by itself. So you can just kick it off and let it go, and it'll keep going. It's just like, it's so nice because it's 126 lines of Python. The entire library is 126 lines, and it is like this beautiful unification thing across all the existing parallel frameworks in Python.
Nice.
Yeah.
So the other question is, what's something that you want to learn next?
What do I want to learn next? I'm going to go with Fast API, I think.
Okay.
I really want to get deeper into that. I also would like to do a little bit more with type annotations. So far, I've used them as editor support.
Like PyCharm?
I want to make sure that PyCharm or VS Code like knows exactly what this thing is, return from this method, and it'll give me autocomplete and type checking and stuff. And fantastic, that's good stuff. But with things like MyPy and MyPyC, you can get like CI level verification that your program is still sticking together and whatnot.
Yeah. So where have you used your type annotations up to now? Like,
the way I try to think about where type annotations go is on the boundaries of application layers. So maybe I've got a data access layer that talks to databases and all that kind of stuff.
Right.
You don't have to go in every single part of your code, overwhelm it with type annotations. But if every top level function in the data access layer talks about what it takes and what it returns, all of a sudden, a lot of the editors can infer as you start using the data access layer, well, you got this variable, then you pass it here. And so it's still one of those things that you described at that one point where it got started, what it is. And so if you just put it on like the boundary of an API, basically,
yeah,
it's usually enough to completely cover what you're doing in terms of getting help from the editors.
One of the things when I did a course based on Gerard's article from Real Python about type checking.
Mm-hmm.
his article is huge, but I called it 101 sort of type checking.
Nice.
And so did a video version of it. And as I, would dive into it, that was one of the things that I'm like, really had a hard time, because I was like, this is something I wanted to learn. The first thing I did was decorators, and then I did that one.
Yeah.
These are like things that I would look at in code and go, what is that? What is it doing? And so one of the fundamental problems I had with type checking was, why would these things be here? What is it doing? And so forth. And then as I did the research, it's all about, intent, right? And like, what is this thing doing? And especially if it's going to talk to something else. Like if your code's going to, like you're saying, the boundaries, like this piece of code needs to talk to a database, or it needs to be part of an API and so forth. And that seems to be like the vital thing, right? Like where type checking is really going to help cover yourself in so many ways, and then also documentation, right? So,
well, yeah, if you imagine that you're creating a package that other people are going to use,
right,
and assuming it's Python 3 only, right? So you're as welcome to use type annotations as much as you want. Maybe that only has 5 function calls, but if you put type annotations on what goes in and what comes out, it's going to be so much easier for people to use your library. Like one of the things that just makes me want to pull my hair out is when I get to some API and it says you create one of these classes and then you go do the thing, which is fine. But then the constructor, the initializer is star args, star KW args. And I'm like, anything could go. I have no idea what goes in here. I have no idea what type goes in here. I don't know how many things. And then you go look at the documentation, and it'll probably say there's some there. Maybe it'll tell you the type, maybe not. Like Bodo 3 from AWS is like this. And then you go look at some example on Stack Overflow talking about how they're accomplishing a thing you can't quite pull off. And they're using a different keyword that's not even in the documentation. You're like, this is killing me. I just want to just go play in traffic for a while because I can't take work with this library anymore. Right. And if you just had default values, named parameters, and type arguments just on like just the constructors or just a few places, like life would be so much better. So anyway, that's my philosophy on them.
I think that's been kind of a little bit of a trend that I've been noticing, and I don't know what you feel on it, is when I started seeing, args and quargs everywhere, and I was like, oh my gosh, this is a super confusing thing too. And it was like, I don't know if it's generally I'm seeing less of it, but it seemed like that was way more common 3 or 4 years ago.
I think you're right. I think we're seeing less of it, and I'm thankful for it.
Yeah. I mean, I think everybody should be, it's just like, tell me what you were thinking here. What was supposed to go in.
Let me throw one more wild idea out there for you while we're on this topic really quick.
Sure.
I talked about Pydantic and Fast API and how that's cool. One of the new beta features that Pydantic, which is the validation layer of those classes that is being used inside of Fast API, they came up with a decorator that will at runtime do checking on your type annotations. So in like C++ or Java or whatever, if you compile your code and you pass an integer where a string goes, the compiler would fail and say, no, you can't put an integer here. It's a string. In Python, that's a suggestion, right? Like, well, it looks like a string, but whatever. We're just going to let it go through at runtime. The Pydantic validator will enforce that you pass the right types that match the type annotations at runtime. So almost like compilation.
Okay.
I don't know if I'm necessarily recommending people use it all, but it's a pretty interesting idea to say you can opt into making these runtime requirements, not just editor helpers.
Right. That makes sense. I guess if you're willing to answer the old question that I had that I kind of retired, is there something that you felt like as you got into Python that you thought you knew, but in the end you were wrong about it?
I like this question. It's a good one. That doesn't necessarily mean I have a good answer or an answer.
Sure. That's okay.
Now, let me tell you what, when I first got into Python, I thought I understood, maybe even like a little tiny bit before I got into Python, and then I didn't understand. But now I think I do. I came from learning C and C++,
right?
Doing C++ as a professional developer for a while, doing like 10 years of C# development, mixing in some JavaScript development. Every one of those languages is about curly braces, semicolons, parentheses, type stuff, except for JavaScript, right? When I looked at that code, it was fine. I thought, okay, well, you've got to have all the types everywhere. You've got to have curly braces around your conditionals and your if statements, as well as the parentheses around the actual condition. And I went to Python and I thought, this is just a weird language. Like the white space mattering, it's kind of weird. The fact that I don't have to type if parenthesis test, close parenthesis, I can just type the test. That's a little bit weird, but I kind of like it. And it took me a couple of weeks to get really comfortable with it. But I still conceptually thought, oh yeah, but like the C style languages, like that's the real programming language. And this is an interesting one, but it's not as legit as that style, right? And then I had to go back and work on this C# project for a while. And what really surprised me was I looked at it, I'm like, I can't read that. Why can't I read all this? There's crap everywhere on the screen. I can't read what it's doing. Even though for like 15 years, I'd like looked at code like that, right? I'm just like, it's so overwhelmed with generic types and parentheses around this and curly braces and and the thing that really shocked me and surprised me was I thought that those things were required. I thought just to properly structure stuff, you really had to have parentheses around like your test and your if statement, and you really needed semicolons to say here's the end. And then I went back to Python. I was like, much better. And just a week ago, I was freaked out by it, right? And now I'm pretty sure as I go back and try to read those languages, it's just harder. And so what I thought I understood about Python was that it was like this sort of cut down, wimpy version of true programming languages. And I just realized what now I understand is like, this is a much better way. And if you look at these real programming languages, C++ or whatever, they've got this baggage that is unnecessary. Like there's no reason for parentheses around an if statement. You can just go without it and it's easier to read and so on and so on. And that really, really surprised me, but it continues to make me happy.
Yeah. Yeah. The visual noise of it makes it kind of unapproachable in a lot of ways. All the symbols or whatever you want to call it. Yeah.
And I got okay with it because I thought this is the real way. And okay, so it's fine. And I was totally, you hear a lot of people complain about those kinds of things that are coming from a place of not having experience with either. And you're like, oh, well, that's just because you're not used to the symbols. Like I did that for 15 years. I was plenty used to it. I still had that feeling. And I just think it's so interesting. So I was wrong that those symbols were one better or two needed.
Yeah, that they had they required to level it up. Yeah, that's crazy.
Yes, exactly.
Hey, thanks so much for coming on the show, and thanks for doing Talk Python for so long. You definitely inspired me to do this podcast.
Awesome. Well, it's been a real honor. I had a great time talking with you. Thanks for inviting me, and congratulations on your show. I know it's off to a good start, and you're doing a great job. So keep it up.
Oh, thanks. Thanks so much. All right, talk to you soon.
Yeah. Bye-bye.
I want to thank Michael Kennedy for coming on the show, and I want to thank you for listening to the Real Python Podcast. Make sure you subscribe to the podcast in your favorite player. And if you like the show, leave us a 5-star rating and a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.